Yaani mami amesema tununue sukuma ya 40. Sukuma ya 40. Unipatie na pesa ya breki. Sukuma ya 40. Baby boy.
Bros? Bros? Gue cewek-cewek di rumah. Rose, unaenda shule kesho?
Kwani? Watu wengi.
Mbona nilianza kwanza kwa
Lazima tuone. Ndio maana kuna kasi.
Hello, welcome guys to this live. We're going to have a discussion of this GCSE Physics Paper 2H, and if you are going to do this exam, welcome to this live, and I really wish you all the best. I would like us to leave comments, and we become quite active in the live section so that I can be able to know, guys, whether you are benefiting. I would like us to start looking at this. Let me get to know those who are joining us. I'm Prof. Nick, the teacher of physics, coming live here trying to support you so that when you'll be doing this exam on Monday, that's on 16th, you will be in a position to answer questions quite effectively in order for you to earn your marks. Now we are going to look at the most important topics, the most important and the key areas that you have to focus on as far as this topic, as far as paper 2 is concerned, that is GCSE Physics. So if you are joining us, feel free guys to write in the comment section, in the chat section, that you are getting ready. So watch and learn, welcome. Watch and learn, welcome bro. Hello everyone. And let me just take this opportunity to welcome you guys to this so that we can be able to discuss this concept of physics. Are you ready for the exam paper on Monday? Are you guys ready? Let me get to here in the chat section if we are ready. Yeah, so the first important topic that you need to be ready, you need to be prepared to answer. The topic that you need to be ready to answer in that particular exam is the question to do with electricity. That's an area that you need to focus on before you sit for that exam. So we are told here in question 1 that a student investigates resistors connected in parallel using number of resistors. Yeah, a student investigates resistors connected in parallel using a number of resistors. Each resistor has the same resistance. Yeah. We are told to add a voltmeter. So something that you need to remember, a voltmeter is added parallel to the rest of the components. When you add a voltmeter in a circuit, it should be connected parallel to the rest of the components there. And we were also asked to add a resistor R such that is parallel to the other. So that is why you can see I decided to add another resistor which is parallel to resistor R. State the measurement that the student should take to check the overall resistance. So something that we need to remember, for you to measure, to find resistance, you need to use the formula voltage over current. So that's the guide we are going to use in order to answer questions here. And then we are going to say that the measurement that need to be taken here is the voltage. The potential difference should be measured. And once the potential difference is measured, we need also the current so that we can be able to use it in order to calculate the resistance. So the measurement that need to be taken for you to measure or to determine the resistance of a component is the potential difference across the components and also the current in the circuit. And for you to measure potential difference, you are going to say that you measure using a voltmeter, and a voltmeter is always connected parallel to any component. So those are the key areas that you need to remember before Monday, before you sit for these exams. Those are the important information that you have to put into consideration. We need also to look at this question here that I asked. A student investigates how overall resistance of the circuit changes when additional. The student investigates how overall resistance changes when additional resistors are added in parallel to R. So Each resistor has the same resistance. The figure shows the result of the student investigation. Actually, whatever that we are having here, this particular curve that we are having here, it wasn't there. So I'm the one who just introduced it so that I can be able to show you what we are supposed to do at that given point. So, which means that state the resistance of a single resistor. A resistance of a single resistor is when there was no resistor added. So in that case, we are going to say a single resistor is going to have a resistance of 1 ohm. Resistance of 1 ohm. Right? So that is why you can see here, you can be able to read that value at that given point. For one resistor, it's going to have 1 ohm. So which means we are just using this value that's here, 1 resistor. Then you go up and you check where the reading is. You read this value that we have at that point. So that's basically what you're supposed to do in that case. Next question that is asked here. Comment on the relationship of the overall resistance and the number of resistors. So if you can be able to observe this graph, this point that were plotted, is that as the number of resistors increases, overall resistance decreases. So we can be able to say here that the overall resistance decreases as the number of resistors increased in this case. And since the graph that we are having a curve, which is not it's not a straight line, that will mean that the overall resistance decreases. But also we need to state the relationship that exists. The relationship that is existing here is that the two relate, they are non-linear. It's not a straight line. So we're going to say the relationship is non-linear because we are having a curve. Okay? And we need also to indicate that when we have two resistors, resistance is 0.5. When you have two resistors, resistance here is 0.5. You can read there. And when you have four resistors, resistance is 0.25. So the relationship is nonlinear. And then you need to just pick a few values and then you can be able to show that when you have two resistors, resistance 0.5. When you have four resistors, becomes 0.25. So which means that the resistance decreases with an increase in the number of resistors. Yeah, so before we move to another topic that you need to prepare on, another topic that is very important, another topic that is going to be tested in your exam, and a topic that we are sure that you will have to prepare on is the topics of what? Moments. Moments. Moment of force. Moment of force. So in this topic, you need to remember a few things. Number one thing that you have to remember for the topic of moment of force is the formula used to calculate moment. Even though sometimes this formula is provided, but you really need to know that moment of force, that a moment is equal to force times perpendicular distance. And also you need to remember the principle of moment. Principle of moments. And principle of moment states that at equilibrium, at balance, when the system is balanced, sum of clockwise moments should be equal to the sum of anti-clockwise moments. So this states sum of clockwise moments. I'll write initials. Sum of clockwise moments is equal to the sum of anti-clockwise and clockwise moments. So this is the principle of moments, and all the moments are calculated from where the pivot is to where the force is acting. So don't forget that before Monday you will be sure that you will be able to do a question that is related to that. Guys, if you are joining us, please subscribe, and also just give a like to this live, share this live, and also leave a comment down below if you are benefiting. Yeah, so I would like us to move together. So guys, kindly leave a comment, give a like to this live, and leave a comment that you have followed. All right, so under this question of moments, we're told a student investigates the moment of forces, and the figure shows apparatus used. In this case, we have a magnet, and then we have the pivot, and then we have modeling clay on the other end. The pivot is under the center. The pivot is under the center of the rod, and then we are told the magnet is fixed at one end. The piece of modeling clay is fixed on the other end. The student fixed a coil of current. So remember, when current flows through the coil becomes magnetic, so it can be able to attract. It can be able to pull the magnet down, and this maybe could be able to maintain the stability and maintain this, make this stable. The coil is connected to DC power supply so that there is a current in the coil. To bring the system back to equilibrium, the student hangs 0.5 Newton weight on the load, and that is 8.4 centimeters away from the pivot. Calculate the size of the force between the magnet and the rod. Yeah. Now calculate the size of the force between the magnet, and we're going to say clockwise moment is equals to anti-clockwise moment in that case, and we're going to say that's going to be 0.05 times 0.84, because the distance from where the the pivot is to where the weight is acting is 8.4 centimeters. So if we can be able to convert maybe if we can be able to convert that to meters, then we are going to say this is going to be what? Let me just convert that. I'll just have to erase this so that we can be able to work it properly. And we're going to say, we are going to say, since these units are in centimeters, both of them, we can decide and work out without doing the conversion. So we can be able to say F times 120 is equals to 0.05 times 8.4. And this, this is, am I just writing this? It's 1 F times 12 is equals to 0.05 times 8.4, which will mean that if we work it out, it's going to be 0.05 times 8.4 divided by 12. So simplifying this, what does it give us? Write in the chat section if you work it out. What will it give you? Just write it in the chat section. Let me know what the answer for that could be. So let me just get to know what's the answer in that particular part. Let me get to know what the answer could be in that section so that we can be able to proceed. Let's write the answer in the chat section, what that could be, what the answer could be. So in that case, if we work it out, that is going to be what? That's going to be 0.05 times 12 divided by 0.05 times 8.4 divided by 12, and if you work it out, you're gonna get 0.035. So the force is 0.035 Newton in that case. So basically that's what we are going to do in that, so that we can be able to get what the answer is all about in that particular part. So what we are going to do in the next part is to look at what another question could be. Describe how the student could develop an investigation to determine the size of the force between the magnet and the coil that is directly proportional to the current. So in this case, what the student will do is to measure the value of current, vary current, and at each instance, measure the corresponding amount of force. So for each particular current, this student is going to vary the current, yes, and then before varying the current, she will measure the corresponding force so that we can have different sets of values. Now, once we have a different set of values at that point, we can be able to calculate the ratio. We can be able to calculate the ratio between force and current. For different current, you get a different value. Then now, once you have gotten some set of values, then you work out the ratio between force and current. Now, you check, is the ratio constant throughout? Yeah. So what I'm trying to say here is, we are going to take a given data. Yeah. Yeah. Then we should, let me just say here, this is going to be, we shall have a table here, and then we shall have another table of values here, and then we shall say at given points here, we shall have current. Then also we shall have the amount of force. So we are going to do this for different currents, and then we're going to get different set of forces. So once we have done that, we are going to do a ratio, and the ratio here is going to be, maybe we can say force over current. So if we try to check, are we going to get constant value there? Are you going to get the same values at this point? And if you're going to get the same ratio throughout, then it will mean that current is directly proportional to the force. And that is exactly what you do when it comes to questions like that. In order to show it's directly proportional, you are going basically to get different values and then find the ratio in order to get it. Question number 3, we are told a rack and pinion system used on a mountain railway is here, and the distance between two teeth on the rack is 8. So meaning that between one teeth to the next, we have a distance of what? 8 centimeters. The teeth of the rack is 8.0 centimeters apart. Calculate how far along the rack the train moves when the pinion turns through one complete revolution. How many teeth do we have in the pinion? We're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 20 of them. So by the time it's making one revolution, we are going to have 20 teeth moving along this path. So we shall have the distance covered 1, 2, 3, 4, 5, 6, 7, 8, 9 until you have 20. So which means we are going to have 20 times 8 over 100. Why 8 over 100? This was in centimeters, so we have to convert it to meters. So it will be 20 times 8 over 100, which is going to be 1.6 meters. And that is going to be 1.6 meters as the distance covered in one complete revolution. Moving to question number 14, that is, we are told a drone of mass 4.5 kg rises from the ground to a height of 20 meters. So we are supposed to calculate the change in gravitational potential energy. So this is another area that is very important that you really have to prepare on. You have to be ready to do a question on gravitational potential energy. And in this case, we are going to say that gravitational potential energy is equals to what? Mass times gravity times the change in height. So in that way, we shall have 4.5 times 10 times 20, which is going to translate to 900. Translates to 900 joules of energy. The next part is stating the amount of useful work done. The amount of useful work done is equivalent to the work done against gravity. And that is going to be 900 joules. It takes 4 seconds for the drone to rise through the height of 20 meters. Then calculate the useful power developed, of which you have to remember that power is equal to the rate at which work is done. So power is energy over time. All power is work done over time. And since the work done here is this, and we're going to say 900 divided by 4, which is going to be 225. When it also comes to do with moments, of course, there's another question here. We are supposed to take moments about point A. So this weight is pulling down, so it's creating a clockwise moment. But this force at B is pulling up, is creating anti-clockwise moment. But if you are using F2, we are going to say F2 times 0.8, because the distance that we are having here, the distance that we are talking about, is the distance from where the force is acting to where the pivot is. Our pivot is at this point. So we are going to say F2 times 0.8 should be equals to 450 times 0.5, because the distance from where the pivot is acting, from where the pivot is to where the force is acting here, we are seeing that the distance is 0.5. So essentially, this is what we're going to do in order to work out the force F, and then we're going to have the force as 281. The next is, of course, under electricity now on resistors, and when resistors are connected in series like this, the effective resistance, the total resistance, is the sum of the two resistors together. Then to calculate the potential difference, we have to remember that potential difference is equals to current times resistance. Yeah, so which means that the current is 0.2, which is here, because for a series connection like this one here, current is the same throughout. So we find first we need to combine the two resistors. We have it as what? 35 ohms. So once you have the two resistors combined, then the potential across the 15 ohm resistor, that's the one that we should focus first, is going to be the current through that 15 ohm resistor times the resistance. So it's going to be 0.2 times 15, and that is going to give us what? this value of 3 that we are having here. But the next question is asking us the total power dissipated when there is a current of 0.2 in the two resistors. So if the power dissipated, power is I squared R, but the total resistance is what? 35. Then it will be 0.2 squared times 35, and that's going to translate to 1.4 watts as the power dissipated, or the power lost through those two components. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do tutorials, you'll be notified. So remember to check our Patreon page so that you can be able to access the PDF of the paper that I'm having at this given point. All right, so moving to the next part here, we are going to look at also current. Electricity is also another question that is quite common. You can see we've already done that. Calculate the resistance. We know resistance is voltage over current. Remember that, 4.5 over 0.3. And power supplied is current times voltage. So since the current is 0.3, and the voltage is 4.5, so you multiply that to 1.35. You need to remember the concept of kinetic energy, potential energy, and also work. So in this case, we are talking about kinetic energy here. So which means that kinetic energy is also the question that you can question on. First, you need to remember the formula is mv squared, where this is the mass and this is the speed at which this particular object will be moving. So once you remember that, you can be able now to find the missing quantity. Now in this case here, we are supposed to work out the mass. Yeah, we are given the kinetic energy as 2,800 joules. The mass, okay, the mass is 85. Then we are supposed to work out the speed. Of course, you are going to substitute everything that you have, and since v is squared, so we have to find the square root of that, and that translates to 8.1 meters per second. Still, this is the question on moments. Already we have worked out a question to do with moments. I feel that we need to move electricity. Also, we have worked a question on that. And power is current times voltage. You have to remember that. Another area that we have not really mentioned is energy. Electrical energy is given by the formula current times voltage times time. Electrical energy is current times voltage times what? Time. So we're going to say that this is going to be IVT. But you ought to remember that current should be in amperes, voltage should be in volts, and time should be in seconds. So that's why you can see we were given in 7 minutes, but I decided to convert that to seconds. So I took that 7 times 60 in order to convert to seconds, so that I got my answer shown here. Already we have done that. And describe the relationship between the current and voltage. So we can see as current increases, as voltage increases, current also increases. And something that you need also to remember is that you have to know the relationship, whether the relationship is linear or non-linear. So which means that you have to know that this is a non-linear relationship because it's not a straight line. And you can see now voltage 20, current when voltage is 1, current is 20 milliamperes. When voltage is 3.5, now it has increased, current also has increased. Calculate the resistance. Resistance is voltage over current, so we have to take 4.5 over 0.051 because we have to convert this is in milliamperes. So you cannot be able to use it, you cannot be able to use it the way it is. You have to ensure that you convert it to the correct manner. So basically that's what we are going to do in this particular part of the question. So also combining forces is another area of interest. So this is two forces which are perpendicular. So you can be able to move one force from one end, then you move it to the other, so that you can be able to work out the resultant force. So our resultant force is going to be this force. So we can be able to use Pythagoras theorem in order to work it out. So we are going to say 20 squared plus 20 squared. For r, we find the square root, which is going to translate to 28 kilonewtons. Yeah, so basically that's what I wanted us to focus on. And then we have here a cyclist on a hilly road. We are supposed to identify the greatest overall gravitational potential energy. You will check where you have the highest height. So between R and S, that's where we have the highest height. And that will give us the greatest potential energy. And then the examiner will be happy if we have selected that point in D in order to earn all the marks. The total weight of a cyclist is 700 newtons, that get the total amount of work done. So we know that work done is force times distance. So if the distance is 20, if the distance you can see from this point to this cyclist, for which region? P to Q. P to Q. From P to Q. So you can see here is 20 here. Yeah. So this height, distance is 20 and the force is 700. So the work done is 20 and 700. That's going to be equivalent to 14,000. And if you are working out the mass, you can be able to use the formula GPE is equals to mgh. Then since we know the GPE for this case is given here, and then we know gravity and we know the height, which is 15 centimeters. That's from Q to R. We are going just to read those values from the graph. Q to R, we shall realize that Q to R, the distance here is what? 15. It's 15 meters. So which will mean that we substitute it here. So we can be able to substitute here and you are going to get 75 kilograms. Explain why the total amount of work done by the cycling between Q and R is different from the change of gravitational potential. This is according to law of yeah, so which means guys, please thank you so much for joining. Thank you guys for joining. I'm glad to have you here. I can see we are having sorry sir, okay, I want you so bad. Go guys, thank you so much. All right. Low soulmate, yes, you have found me, bro. Let's learn physics. This is GCSE Physics Paper 2H. I believe you are prepared and you are ready for the paper. Yeah, so I believe you guys, you are benefiting and all right guys. All right guys, welcome guys. I'm glad to have you here. So I believe you are following, and just leave a comment if you are benefiting. So the reason as to why the gravitational potential energy is not equivalent to the amount of work done is because some work is done against friction, some work is done against air resistance, some work is done to overcome air resistance, and also it will mean that some work, some energy is dissipated or some energy is lost to the surrounding. So basically that's why extra work is done at that given moment. Yeah, so guys, sorry for this reference. That is my small boy who was with me, wanted to learn it. He has left. He has left for us to learn in peace. Yeah. I believe you are benefiting. I believe you are getting value from this live as we proceed. So something that we need to realize is that some energy is going to be used to overcome friction, and that is why part of it, give me that. Thank you, sir. Yeah, so some of the energy is lost to the surrounding, and that's why you can see more work is done, yeah, than the gravitational potential gained. Yeah, so some energy is dissipated to the environment, some energy is lost. The cyclists lubricate the chains and the wheels bearing for the bicycle before setting off. This is meant to increase the efficiency, because if there will be a lot of friction, yeah, remember lubrication is meant to overcome friction, to reduce friction points. So this one now is to increase the efficiency of the cyclists and the bicycle, so that the amount as the cyclist cycles is going to all the energy is transferred to move the bicycle, not to overcome friction. So a lubrication is for efficiency. Guys, I believe you have gotten value from this particular live that I've done. Right now I'm working on another set of topics, so that tomorrow we are going to have another live on the same, so that by Monday, as you are preparing, by Monday you'll be really ready. So guys, let me get to know. Let's write in the chat section, which topics do you feel I really need to focus on the next live, so that I'll select and sample those topics together, and then I come up with the areas. Yeah, so let me just write in the chat section the topics that you feel that in my next live I should focus on, so that I can be able to support you the best I can. Let's go ahead, write the topics that you have a challenge. I can see this guy has written electromagnetic waves. F has written generator effect, motor effect, Fleming's left-hand rule. I'll work on that. This guy has also added a statement saying electromagnetism. Yeah, I'll ensure that is in place. Tomorrow we shall meet same time, and I think our life is going to be a bit longer than what's done today, so that we do it on Saturday, that is tomorrow, and Sunday, so that by Monday you are ready to go for this. Thank you guys for this. Thank you guys for being with me here. If you have not subscribed to Proplan YouTube channel, bro, just kindly subscribe, so that anytime I'm going to do more tutorials, you'll be notified. And if you have not joined our Patreon page, just join there, so that you can be able to download the PDF of this paper that I was working at this given point. Guys, I wish you the best. I wish you good luck in your exams. Continue revising. See you tomorrow. See you tomorrow. See you. See you tomorrow, guys. Same time, same place. If you did not like the live, like it. Share the channel to your friends. Tell them to join us tomorrow. We shall pick from there. I believe the live was of great help to us. I'm just uploading this PDF right away, so that you can be able to download it. Let me just upload this PDF. Let me upload this PDF. I share the link. Before I leave, let me just upload this PDF before I leave. in order for you to download it. I don't think whether it will take long, to just take a second for us to let me just upload it, and then you confirm that you have gotten it, so that I'm very sure you've gotten it, guys. Let me just upload it. Let me call it GCSE Prep 2H 2025. GCSE Prep 2H 2025. I'll upload the so where is this? Yeah, I'll upload both of them so that guys, please, can you confirm once I've done uploading, confirm that you have gotten it, so that by the time I'm leaving, I'm sure you got it. Yeah, let's continue writing the chat section, the topics that we feel that I should prepare for the next live. Yeah, done. Now let me just post the link in the live section. Yeah, the link is there, guys. The link is here. Use it to access that PDF, and let me get to know whether you have received it before I end this live. I'll be glad to know that you have received it before we end the live. Because tomorrow we shall meet and discuss those topics that we haven't discussed yet. Oh, I think there we are. And oh, I've realized I've not included the handwritten. Let me just include the handwritten so that magnetism MS question magnet. Yeah, so let me include the handwritten, guys. I'm just including the handwritten right away so that we can end there. Yeah, now I've included all the PDFs in that link. Yeah, so can confirm. Can you release over required practicals? This is done. Yeah, so all that's required practicals. So I will talk about that tomorrow. I've put it in the section. If you can please also go over loudspeakers. Yes, I will do that. I will do that. I will do that. Loudspeakers. I've taken note of this. All these requests, I've taken note of them, so that tomorrow when we are meeting, we shall be able to go through them. So loudspeakers, guys, thank you so much, guys. I believe the live was of great help to us. See you tomorrow.